Here is another example of an isobaric problem. An insulated piston cylinder device with 5 liters of saturated liquid water at a constant pressure of 175 kilopascal is stirred by a paddle wheel while a current of 8 amps flows for 45 minutes through a resistor is placed in the water. If 1/2 of the liquid is evaporated during this process, and the paddle wheel work amounts to 400 kilojoule, determine the voltage of the source and show the process on the PV diagram with respect to the saturation lines. Follow the same 4-step problem solving procedure. Identify system, process, and substance. Fill the tables. Determine work. And apply the corresponding first law. So, from the problem statement, we know the substance is water. And there are 2 processes involved. The piston cylinder device used in the problem indicates that the process will be isobaric. Our system will be closed, so my mass will stay constant. And one more important process as identified in this problem. Since the piston cylinder is insulated, insulated implies that there isn't any heat flowing in and out of the system, so my Q is equal to 0. Following step 2, let's try to complete the table. We first populate the table with the givens in the problem. 5 liter, my initial state, volume. Saturated liquid, initial state, phase. Constant pressure, 175 kilopascal for pressure for both state 1 and state 2. 1/2 of the liquid is evaporated. This indicates to me that state 2 is at a phase of saturated mixture with the quality given at 0.5. We then go through the looking up the table procedure to find rest of the missing properties. Since for both cases there are 2 intensive properties provided, it should be relatively simple to find rest of the missing properties. One thing to note, since the system is closed, my mass is going to be the same at 4.731 kilogram. And this slide shows all of the properties found. In step 3, we now need to find work. From the table, we should be able to identify pressure and volume for both state 1 and state 2. And they can be identified here and specified on the PV diagram with respect to the saturation lines. As you can see, the process from 1 to 2, because it's isobaric, turns out to be a straight line. My boundary work then can be found using the area under the curve here. The area actually is a rectangle. It is relatively simple to find the area of rectangle. Its height is 175. Its width is the difference of the 2 volumes. After plugging the numbers, we found that the boundary work is 404.75 kilojoule. Paddle wheel work is given in the problem at 400 kilojoule. Since paddle wheel work is always work into the system, it will always be less than 0. Therefore, we write paddle wheel work as a negative 400 kilojoules. Electrical work is given as voltage multiplied by current by time. The unit of the time needs to be in seconds, therefore we convert. The division by the factor of 1,000 is necessary to make sure the unit of electrical work is in kilojoules. And electrical work is also work input into the system. Therefore, it will always be negative. In this case, voltage is an unknown. Therefore, we will leave it in the equation as an unknown. And we found that the electrical work turns out to be minus 21.6 multiplied by volts. We're now ready to apply the first law. From the problem statements given, we know the system is insulated, which implies that Q is equal to 0. We know the first law is equal to Q equal to work plus change in internal energy. And plugging all the work we found on the prior slide, plugging the number for mass from the property table, and plugging the internal energies from the property table, we then can solve for volt, since that's the only unknown I have in this particular equation. And we get the final answer to the problem that my voltage is 224 volts.